Okay, we are determining the enthalpy change of an aqueous solution, and in the first problem, you're combining 500 milliliters of 2 molar barium nitrate solution at 22.5 degrees Celsius in a coffee cup calorimeter with 500 mils of 2 molar sodium sulfate solution at the same temp. You're forming a white precipitate. The maximum temperature reached is 25.6 degrees Celsius, and we want to calculate the molar enthalpy of the precipitation of barium sulfate. We need to write the balanced chemical equation. Since I'm combining barium nitrate and sodium sulfate solutions, this is a double replacement reaction, you're going to produce sodium nitrate. You're expected to know that all nitrates are soluble, and barium sulfate is your precipitate. We first need to figure out, since we're calculating the molar enthalpy of precipitation, we're going to need to figure out how many moles we've got reacting. So if you convert milliliters to liters by moving the decimal 3 places to the left, and you multiply liters times molarity, you're going to end up with a mole of each reactant because the quantities are the same for each and their concentrations are the same. So we're going to calculate heat, which is from Q equals MC delta T. You want to combine the milliliters of each reactant. 500 and 500 is 1,000 milliliters. Milliliter is the same thing as grams. So that means we have 1,000 grams for our mass times the heat capacity of water, which is 4.18, and then your temperature difference, which is T final minus T initial. I ended up getting 13.0 kilojoules. I converted my joules to kilojoules once I got that. Now, what you want to do to calculate the molar enthalpy is you want to take the Q and divide it by moles. So I take my 13.0 kilojoules and I divide it by a mole, and that gives me units of kilojoules per mole, which is molar enthalpy. Okay, and since the temperature rose in this process, that means that your that means that your H is going to be negative, and you're done with number 1. Okay, for number 2, we have another coffee cup calorimeter problem, and this one contains 50 grams of water at 20.73 degrees C. We're putting 2.13 grams of ammonium nitrate into water. The temperature falls. And so since the temperature is falling to 17.41 degrees Celsius, then what we're going to do is we're going to calculate the molar enthalpy of the dissolution of this compound, ammonium nitrate. Okay, so we're going to take our mass of water, 50 grams, and we're going to combine it with our mass of ammonium nitrate, which is 2.13 grams. That's going to give you 52.13 grams. And then we're using the specific heat of water, which is 4.18. And then your difference in temperature is 25.6. I'm sorry, I'm looking at the wrong problem. Your difference in temperature is 17.41 minus 20.73. Okay, so here you're going to end up with negative 723 joules. Okay, so you're going to convert, because we need to get moles now that we've gotten our Q. You're going to need to get your moles of ammonium nitrate. So if we get the molar mass of ammonium nitrate, it's around 80 grams per mole. That's going to give you 0.0266 moles of ammonium nitrate. So that means your enthalpy of your molar enthalpy of dissolution is going to be your Q value. I'm going to convert that to kilojoules, which is going to be 0.723. And then you want to divide it by moles, which is 0.0266. You're going to end up getting 27.2 kilojoules per mole. Okay? Okay, now On the third problem, you're combining hydrochloric acid with barium hydroxide, and you're producing barium chloride and water. They want to calculate the heat released when 300 mils of 0.5 molar HCl is combined with 100 mils of 1 molar barium hydroxide. The initial temperature of both solutions is the same. It's 21.55 degrees Celsius. The mass of the mixture is 400 grams, and the heat capacity is the same as that of water. They want to know the final temperature of the mixture. Okay, so let's calculate the moles of hydrochloric acid and the moles of barium hydroxide. Okay, now we had to figure out what the limiting reactant was, and based upon the quantities and the coefficients, it looks like HCl is your limiting reactant. And so I'm going to go ahead and calculate Q. My combined mass was 400 grams. My heat capacity of water is 4.18. My difference in temperature is T final minus 21.55 degrees Celsius. And your Q is actually going to be, you're going to have to take this limiting reactant, and in the problem, they gave you a balanced chemical equation. And on the product side, they told you you have 118 kilojoules per mole, but the coefficient in front of HCl in the balanced equation is a 2. So you put the 2 moles of HCl here, okay, so that this can cancel. So 0.15 times 118 kilojoules is going to be 8850 kilojoules. Okay, that's what I need for my Q, but since this has units of joules, I'm going to convert that to joules. And then we're going to go ahead and solve. And then once you figure out what this is, add 21.55 to that side. You're going to get your final temperature is 26.8 degrees Celsius.